So this lecture is on the product rule and the quotient rule of differentiations. First, we're going to talk about the product rule. The product rule says if you multiply two functions f of x and g of x, and those two functions are differentiables itself, then the derivative of the products f of x and g of x equals to the function f of x times the derivative of g of x plus the function g of x times the derivative of f of x. How can we come up with this rule? Again, we want to use the limit process, the definitions of the derivative using the limit process to show this rule, right? So this is the functions f of x times g of x here. You put it in the definitions and you manipulate the algebra a little bit here, and you split the two, the functions, the big function into two different functions. And in each of the function, you can see that this is the f of x plus delta x times, this looks like the derivative of g of x, right? When delta x goes to 0. And again, in this function, you will see the derivative of g of x times, the g of x times the derivative of f of x here. And as the result, the derivative of f of x times g of x equals to f of x times g prime of x plus g of x times f prime of x. And again, we know that the limit of f of x when x goes to delta x when x goes to 0 equals to f of x, because f is given to be differentiable and therefore is continuous. So that's why this is true. This is the product rule. How about and then once we know this rule, then we can start doing problems or start finding the derivative of functions that involved. Let's look at example number 6 here. You want to find, given the functions f of x, you want to find first the derivative of f of x, and second, you want to find the derivative of f of x at the point C. Okay. And f prime of C. So, and then these functions here is a functions that involved a product of the two functions, right? X cubed and 3x squared plus 2x. So then we can use the product rule to find the derivative of f. Equals to the product rule, say you take the first functions, which is x cubed, multiply to the derivative of the second functions, plus take the second functions and you multiply to the derivative of the first functions. Okay, so first function is just the first functions, and the derivative of second functions is you're going to use the power rule and the constant multiple rule. So it will see it's going to be parenthesis. So 2 times 3 will be 6x. 2 minus 1 is 1. So 6x plus 2 times the derivative of x is 1. So 2 times x, the derivative of 2 times x is 2. And then you add, again, you keep the second functions here, and you just find the derivative of the first function, which is 3x. 3 minus 1 is 2. Okay. And if you want to multiply, you want to distribute it out and simplify it, it's great. So if I want to do that, I want to distribute it in here, which gives me 6x to the 4th plus 2x cubed plus 3 times 3 is 9, x squared is x to the 4th plus 2 times 3 is 6, x to x squared is x cubed. And then I can combine x to the 4th, x to the 4th, x to the cube, x cubed, and which give me 15x to the 4th plus 8x cubed, which is my f prime of x, right? So I found f prime of x, and from f prime of x, I can find f prime of c when c equals 2. That means I just need to plug 2 into the x's to find the answer. Okay. And I just put in the calculator and calculate this. So the idea is first you find the derivative of the function using the product rule. And once you have the derivative of the function as a function, then you can find the derivative of this function at any given point. And again, the derivative of this functions, the f prime of 2 here, will tell you the slope of the tangent line. To f of x at x equals 2. So that's what it means, right? Once you calculate this number, you want to have the slope of the tangent line to the function f of x here when x equals 2. Okay, next you have another